Well, it's taken a while to get back around to it, but I am finally down to getting some of the electronics attached to the stove. I'm using my favorite implement, hot glue. I use it a lot in my electronics projects because it's a great insulator. It's great for mounting any conductive material like solder joints, to keep solder joints from grounding out. Of course, in here I'm mounting it on wood, so it wouldn't have mattered. But in my servos, you may see here, if you can see in the camera, I've actually built up quite a bit of hot glue around them. That's not actually holding them in. That's a snug fit, but that provides a true connection, and it keeps them from turning, and it keeps a good solid reference point when I bolt these in. I'll actually bolt them in with a little plumber strap. Ideally, I would have a piece of wood that comes up underneath this little mounting tab here, and have those little screws that come with it would bolt on. And yeah, this is not the ideal, but that right there actually will hold it for what it's going to do, because the torque is going to be against the body and it can't move at all. But I will go back and put a little strap on the top of them to hold them in. And I've got one up here in the front that's the same way. I don't have the servos actually sitting over here out of the way. And I've got the Arduino positioned somewhat in here, just so I can get this board in. And right now I'll do that little nut. Here it is. I am bolting on the heat sink, or the case of the control box, which will serve as my heat sink for the little voltage regulator that will provide a solid, consistent 6 volts to the servos and to this big heavy-duty cap that will maintain 6 volts as the servos kick into gear. It's a good idea to put at least some capacitor next to any driven device, motors especially. I don't have the wrench I need. For the time being, I'll just use pliers, just to provide any voltage drop. These servos, their most torque is when they first kick in. I need as much torque as possible, so I don't want them coming on and then going into a pretty much immediate low voltage or under voltage state, like waiting on line, but the voltage coming from the umbilical or the control cable connection. That won't be much, but with a load, it'll be it's maybe a half a volt. So I'll be asking this servo to do a pretty heavy job. Instead of giving him 6 volts, what she wants, I'm giving him 5.5. So this little voltage regulator, it's coming into this box at, I think it's going to be coming in around 10 volts after the voltage drop of the connection and the small copper I'm coming into this box with. But then it'll go in. This will actually be inside. It's a different chip. This is just my little prototyping board. All of this will come in and just be wired connections to this device. And then it'll take that 10 volts, run it through this regulator, and produce a solid 6 volts, which will charge this cap. And then I've got 2 little connections over here that where my servos hook in, and then the servo lines, these white wires are the servo signal lines. So I'll get ready to test this. I got my little power supply over here. This is just a converted power supply out of a computer. I've got a little 3 volt status light here. I've got a 12 volt lead that goes to the Arduino, just a standard plug, and that'll fire the Arduino at 12 volts. And then I've got an accessory loop coming off that goes to my servo, actually goes to my board, and then that's the 12 volts that'll feed this regulator. So at 12 volts, this guy gets kind of warm. So that's why, I'm dissipating 6 volts Very little wattage, but 6 volts into basically just heat. So that's why I need a voltage regulator and a heat sink on it so that it doesn't overheat. So I'm gonna power up the plug this guy in. Got my laptop over here. I'm sure I'll plug him in just shortly. Let's see, just so I can see what's going on. I'm going to tweak these a little bit. But right now, both of these are just set to do I think it's a 90 or 120 degree swing. Okay, signal wire is toward that. And make sure I get the signal wires right. I have to short out the overload the potentiometer in those relays or the servos. Not expensive, but I don't really want to replace them. So, signal wire is white and it's to the front of the. It's white on this coming into this board. It's yellow on the harness going to the servo. The other two are just plus and minus 6 volt DC or positive 6 and then ground. Let's see. Okay, now when I fire this up, it still has it in its memory. Let's see, port 9 is what I'm pulsing my signal out on, and I'm duplicating it on this little breadboard and sending it over to both servos. And I've got a port on here that I can actually power the servo. I've also got a link wire, this little black wire coming back over and hitting and touching into ground. This just provides the reference ground for the signal. It ties the reference ground for the signal on the daughter card to the main card, so we have an equal 0 voltage. Otherwise, it makes the servos do weird things because they can't. 0 may not be 0 on this card versus that card without that little signal link. Essentially, these are very simple. They're pulse width modulations that you can kind of think of as serial communications. So it's just communicating a single wire that's pulse width modulated, and then it also runs the ground for the PWM is the ground wire coming from the power supply. So the return of that signal back to the board is through that ground reference that I have to have hooked up there. So that's just basically a transmit and a signal ground of a serial communication line. Anyway, let's see. So let's power up the power supply, and let's see if we can get these servos to actually come to life. And see the Arduino. Oops. Come alive. Okay, Arduino's online. There's the servos twitching. Zoom you in a little bit. So there's the close-up of the power supply, the onboard, and you probably won't see that one moving much because it doesn't have a horn on it. This one has Alexa. I'll give it a shot. Let's see, that's just a little test program that swings them back and forth. I don't know if you can even see that. So it's just doing basically 90 degrees. Positive 90, negative 90. About once every 3 seconds. So in this case, it's keeping that little guy cool. And the next thing I need to do is figure out how I'm going to actuate. I'm going to move you back a little bit so you can see. Excuse me, I'm fighting a little cold here. I don't know if you can see in here, but I've got this little metal arm. That's my exhaust damper. control, and I've got to figure out a way to. He's going to move quite a bit. I think what I'm going to do is take this little servo and put 4 little screws on him in 4 little places, and basically use him as a winch. So he'll turn. He'll be at negative. I see these are 180 degree swings. So he'll be at negative 90 at rest, and then he'll go to positive 90, 180 degrees of swing, and hopefully I'll have enough that I can actuate that to. This arm needs to move about 2 inches. At rest it's closed. Half open would probably be enough. That's 1 inch, and then about another inch and a half to full open. But let me get set up for that, and I'll be back in a bit. Clearly I need some more adjustments on this, but it is operating the intake damper. It's actually swinging it more than 40 degrees. It's swinging about 55 degrees. Put a little longer horn on it than I had anticipated, but it's what I needed to do to make it to work. And it is adjustable, but when it's closed, it's almost closed right there, and then it's open and starting to close again, which I can tweak that with the programming. So let me show you my little horn that I built. I started off making this with epoxy, and epoxy just did not have the ability for the torque that I needed. So what I've got is a little piece of plexiglass. Zoom in a little bit. That I've heated and bent, and I've got a little adapter that I threaded. That's a number 8, 824, I believe. That is that little metal slug with the set screw in it that attaches to the little 1/8 inch, 3/16 1/8 inch rod, and it just exits the right up in here. It exits the case through a little rubber wiper, trying to keep some of the water out. And so that little piece of plexiglass goes up onto the round horn on the for the servo. Actually, it's underneath the screw, so it's bolted to the horn. And then I've just got right now I've just got a little pop rivet that I've heated and melted down to the horn. Now I will cut that off and put epoxy over the whole top of that so that it looks a little more professional than that. But right now I'm just letting it cycle to make sure it can swing its full radius, and to work that little rubber wiper over here on the side so that can get. I was a little cold when I first started, and it didn't want to actually move. I need to put one on this side too. But I will have a little drain in the bottom of this box, so any water that does get inside during the rain can just weep out. But there's servo 1. Servo 2 is spinning, but he's not got anything attached to him. So that's my next project, is to hook servo 2 up to the. Well, let me see if I can zoom down. My tripod will let me do this. There's the Arduino hanging off the side here. It's actually the brains of everything. That's the Arduino Uno. The Arduino Micro is still in the shop, and that's what I'll actually, once I get all these outputs defined, I'll actually convert the code for the Micro. And the Micro's about 1/3 that size, and the Micro will actually be in the case. And I won't do it originally, but eventually I will come back and put an LCD display with a menu system so I can go through it and look at what's going on. But the first revision is just going to be a USB out going into a computer in my basement, so I can sit there and read all the parameters, and then I'll eventually upgrade it to the LCD and put all the bells and whistles on it. I just want to get this working. It's getting colder already. So hopefully by sometime mid-January, when it gets really cold at night around here, this will actually be able to fire this up and supplement heat to my house. Okay, there's the little axle going down. I get focus here. And so that's the linkage rod. And as I roll that up, so that right there all the way is it's almost full open. It's probably about 80% open, which is probably all I'll need to run it. And then that is fully closed. And so this swing you around to there's that rod again. And it runs up to the very end of the pipe exhaust. So there's the action. There's fully closed, and there's almost open. Now above that, I'll have a little adapter, and I'll go from there to 4-inch stovepipe up another 4 or 5 feet. So there'll be plenty of draft wanting to pull. So just a little bit of open and a little bit of heat through there, and it'll create a pretty good draft, sucking air in this other input and all the gaps in it. So I don't need a whole lot up there. I need that actually to stay fairly closed. Let me get another shot and I'll show you that butterfly in action. Okay, so here's the other end of that. And this is the rod, and this will be almost fully open. That's the end of the stroke. And then, come on, work with me here. It's made to be operated from the other end, so it doesn't like to be operated this way. Got a little spring in that hole anyway. So then when I go down, it closes off almost completely. I got a little bind because of the, but you see how that'll close off almost completely. I've got a little bind over here in my, yeah, there it is. There's the reason. It's hung in my servo. Anyway, so there's fully closed on that lever, and that equates to fully closed here. And I mean, this is better than I thought. This may be 95%. There's probably a little gap around. There's always going to be a little gap without putting a high temperature silicone gasket around it. But that right there is close enough for what I need. So just a little bit of gap gets pretty good hot air flow. And once that hot air escapes into this longer tube that will be out here, then that's going to create a pretty strong updraft. So it won't take a whole lot of opening to provide a good pull into the rest of the stove. So I'm going to turn it off here, and when I come back, I will be hopefully operating this flapper valve with the servo. Well, it took a little bit of ingenuity. I don't have any really fine thread, which is what I'll eventually put on this little guy. That's some 22 gauge speaker wire or audio wire, microphone cable. But there's my little 4-posted bobbin hooked to that little pin on the anchor. This is all designed to be operational when upright. So this little axle has actually got some slack in it, and it can move up and down. So that little bolt right there, you can see it under there, that's just actually holding it off the bottom. And I'll leave that on there. That's a limit to make sure that it doesn't walk back toward the and walk out of the way of the little mini winch won't work. But since I've got it laying on its side, there's the linkage that goes to the front, and I've got it ran over here to a weight that it lifts. That's simulating gravity for the moment. Make sure that it has a return. So then that does actuate all the way to the end, and it's just swinging every 3 seconds here. So it's actually opening a fair bit, though. If I get that to focus. So that's a fair amount of opening. I think that'll do. I can adjust a little more throw if I need to, but I think that's probably enough. But that would be rolling right there, and then that would put the brakes on it. So anyway, I think so. I've got it kind of halfway working. The next thing I'm going to do is button it up, unwire everything in there. That's kind of in a test mode right now. And now I've got the prototype / test mode. I've got to go back and rebuild this with the micro instead of the Uno. So where I'll take the temperature readings, and if it's getting too hot, then I'll start, these servos will become active and start shutting down or turning on more heat. Yeah, just a moment. There's one of my redneck neighbors. I have no idea what they're doing. He needs a muffler or something, or I don't know, maybe he likes it that loud, but anyway. So that's where I'm going to leave you today. I'm going to close this lid up and looking at a tractor. But until then, I have to use the overhead come along system. Let's see, there's a 12 volt. And I'm going to need these wires. Ground. It's kind of a weird color scheme. I've got green. Green is my actual ground. Black is my signal ground. So my whites and blacks stay together, and then my red and green. Nice Christmas music in the background if you hear that. Red and green, my Christmas colors, are actually my power wires coming and going. So all that inside there and close the lid, and yes, the lid does close. It's amazing. Cold out here. Whew. I'm gonna go to the shop. Go to the house. I gotta get some heat installed out here too. Bye for now. Hey YouTubers, this is Chevy Fan 1958. I'm going to explain what I tried to do just a minute ago. I've got about a 4-foot stick of this stuff right here. This is 4-inch pipe. I think it's schedule 40. It may not quite be schedule 40, but I've got quite a bit of this stuff that I bought from Scrapyard. And I had a 4-foot stick of this, and what I attempted to do is take two cut pieces that are probably a little wider than this, cut it in half, and then saddle these on. Actually welded two of these saddles on the bottom of the stove, and then sat this on top. So I set the stove on top of this and greased that area. And then once I did that, I went around and welded little tack welds, little 1-inch tack welds, pretty much all the way around this. About every weld an inch, leave an inch, weld an inch, basically. I'm just making a little raised lip so that when this is rolling as a wheel, then this saddle will butt up against those little beads and prevent this axle from walking out this way. Because on the back of the stove, my control box is right here, and if this axle were to walk out, then it would take out my control box. I'm telling you this now because I just tried it, got about halfway across the yard and just gave up. It is going to work, but we've had so much rain here lately, like 5 inches in the last week, that my yard, which is pretty much a little bit of topsoil over a lot of bit of clay, it's just sliding. This whole thing is just sliding. It's just tearing up my yard. So, well, though I don't have much yard, I'm going to wait a couple days until it dries out, and hopefully it'll work and I'll actually get some footage of it actually rolling. But right now I'm halfway to the landing pad. I don't have very much light. I might take you over there to show you the landing pad, if I have enough light out there. Okay, I'm on my back deck and I'm looking down at the concrete pad. Let's see if I can zoom in here, see if we can get a little better shot of that little riser pipe on the right. This little piece of PVC sticking up, and that's got my communication cable in it. And that little post, looks like a one post here, there's actually 2 1/2-inch galvanized pipes sticking up out of the concrete slab. And then on top of that we'll have 2 1/2-inch boiler drain valves that will connect to the water hose. So basically the stove will hook up to those standpipes with a set of hot and cold washer fill lines. So I can valve off both pieces, and during the year the stove will be sitting there, but I can valve it off and I can actually disconnect the heat exchanger and hook it up to another tank and holding vessel, so I will actually be able to generate steam with this, and run various steam projects in the future. So this is a dual purpose multi-fuel boiler essentially. But eventually there'll be that big chunk of steel that I've been working on now for 8 or 9 months, it seems like. I think it's only been since July. Planted right there, and will be valved in, and then I'll start working on hooking up all the wires, and actually I've got to do a little more work. You can see maybe in this little trench over here, it actually comes over to the house. You may not be able to see this at night. It actually comes up. I'll get a shot of that, and I may not be able to see that. That's actually where it enters the basement, and not much light out here. So I've got some hoses that I was using from a couple years ago when I was kind of testing all this, and they're kind of laying out here in these little noodles and insulation and pipes. So right down here, you might be able to see where those come up the side there. Those 2 galvanized pipes come up and stop there. There will also be from that point, that's 1/2-inch. I'll dump that down to some little 1/2-inch to 3/8 inch bushings, and then those are 3/8 inch. They're just PVC coated airlines. They're vinyl reinforced airlines, like for what you buy at Lowe's or wherever. I've tested them they work fine with up to 250 degrees, and they work fine under steam pressure, up to 5 to 10 pounds. This system is never designed to run 10 pounds. It should pop off at 5, and the controls should shut the fire down before it gets to that point anyway. But if all else fails, the catastrophic failure will be outside, and there should not be any pressure going in. I've already mentioned in previous videos, there is a check valve just inside that wall to prevent pressure from basically blowing out into the basement. So that's what I got right now. I've still got to clean this mess up. There's the form from when I poured that about a month ago. So I've got a lot of cleanup to do out here. So the next shot will hopefully be in the daytime with it sitting here and maybe even valved in with the heat exchanger in it. But that'll be next video. So thanks for watching. Please like, subscribe, comment. This is Shady Fan 1958.